Hello and welcome to our virtual lunch and learn today. We'll be talking about ProSoft connectivity solutions for water and wastewater applications. My name is Rachel Green and I'm the Digital Communications Specialist here at McNaughton-McKay. And presenting for us today will be two of ProSoft Technologies experts, Brian Allport, Global Business Development Manager, and Victor Parangelo, Regional Manager. Out in the comments section, ready to answer your questions, is McNaughton-McKay Systems Engineer, Kaz Viscontis. We'll also have a Q&A portion at the end for Brian and Vic to answer your questions in more depth. We'll be getting started shortly, but we'd like to allow a few minutes for attendees to join us here. As you come in, let us know where you're joining us from in the comments section. You can view recordings of previous virtual lunch and learns on our YouTube channel under the Virtual Lunch and Learn playlist, and we cover a new topic every Wednesday at noon, so be sure to join us on your lunch break. Hi, Kaz, I see you're out there in the comments. For anyone just coming in, welcome to our virtual lunch and learn today, ProSoft connectivity solutions for water and wastewater applications. Let us know where you're joining us from. Hi, Tom, thanks for joining. We'll be looking for your questions as you have them in the comment section while our presenters, Brian Allport and Victor Parangelo of ProSoft Technology, talk to us about the solutions for water and wastewater communications challenges. Our specialist, Kaz, is ready to respond to your questions in the comments as we go along, and we'll also have a Q&A segment at the end of the presentation. Hi, Timothy and Steve. Thanks for joining us here. If you'd like to reach out afterward or if you have further questions, you can send us an email at macandmaclive@mc-mc.com. Be sure to let us know which session you attended. And we will also have that email address on the screen at the end for you as well. All right, we have a number of attendees here with us now, so let's go ahead and get started. Brian, I'll pass it over to you.
Okay, thanks, Rachel. Hello, everyone. I'm Brian Allport. I'm responsible for global business development with ProSoft. And with me, as Rachel says, Mr. Vic Parangelo, who's our regional sales manager in the Northeast. So you see here that we have a presentation that's focused on how to connect each part of your water, wastewater application. So from the ProSoft perspective, the water industry is a target industry for us, which means that we focus on helping you solve your connectivity challenges in this industry. It also means that we develop specific technologies for those applications. We actually have a global water wastewater industry team. Vic's the leader of that team, so he's a great resource for us through this session. So we know from the ProSoft perspective, we know this industry faces a unique set of challenges in terms of modernizing your equipment and connecting all of the different pieces of your application. And it's exactly this that we're going to focus on through these next few slides. So we'll take you through, you can think of it as a smart water journey, starting at the edge of your application, where you may have some antiquated technology that you may need connected to newer technology to better digitalize your plant. Under that same theme, we'll then walk through how ProSoft can better connect to similar systems that you may be using, leveraging different protocols, and how we can help you improve the data integrity of your application. Then we'll take a step back and show you how we can help connect all of that automation at the network level, whether it's networking your equipment in the same plant or networking your equipment that's geographically dispersed throughout the application. It's all good stuff. I think you guys will enjoy it. But first here, real quick, to help you guys understand where we're coming from, I've got a snapshot of who we are as ProSoft. Our business is over 30 years old. We're based in sunny California. Our focus has always been on industrial communications solutions. We're best known for our industry-leading protocol converter business, but our fastest growing portfolios are actually our wireless Ethernet and our ultra secure cellular portfolio, which is really ideal for connecting dispersed assets, especially in this industry. So we'll show you here through these next few slides that if you have any challenges on the communication and connectivity side of your application, whether it's through protocol integration or the connectivity of remote assets, ProSoft is here to help. So with that in mind, let's jump into this with a big picture of what a water application may look like. So there's a lot going on in this image, and we'll actually come back to this image and zoom in on the technology that we're going to talk about through these slides. So it's good for us to get a little familiar with the general overview of what we're looking at now. So you can see, and you guys know this, freshwater application starts with freshwater. You've got your canal, you've got your reservoir at the bottom left here. Then you can see some pump stations with some automation moving this water up the image to the treatment plant. This treatment plant is likely where the SCADA system is. It also facilitates several other functions in the process, each which comes with its own batch of automation. You have automation on the clarifiers, automation on the filtration system, automation through the disinfection and chlorination process. Just in this water plant, you have different field devices talking different protocols, some old, some new. But what they all share is that they're all a critical part of this process. Then outside of the water treatment plant, you have your pump stations pumping the water to the right of the image and water towers to provide this fresh water to the end customer. Again, each part of this process has automation components. So you see here with this bird's eye view of what we're about to go through. And of course, it's very similar on the wastewater side with all these different islands of automation through the process. The automation challenges, water or wastewater, are the same. And your journey through your smart water upgrades are the same. And we can start this journey by focusing on improving your connectivity through phased modernization of all the different parts of your site. And right here, I'll hand it off to Vic to explain this in a little more detail.
So thanks, Brian. Good afternoon, everyone. So I'm going to talk a bit about modernization, specifically as it pertains to water and wastewater infrastructure. And I'm going to talk about phased migration versus rip and replace. So as we go on to this next slide, you know, I promise this is the only slide where I'm going to make you do any reading, right? So besides the obvious things like reducing downtime and risk mitigation, there is zero tolerance for failure when it comes to water, right? I mean, you can lose your TV signal, you can lose power to your home, you can lose your internet, but can you imagine, you know, turning on the kitchen faucet or getting in the shower and it's like no water today? I was watching the news recently and they were talking about water problems they were having in Missouri, and they interviewed a local town official, and he actually said this. He said, our water municipality is basically two old guys who used to be plumbers. So, you know, based on hearing that, I thought this cartoon was apropos. So I'll ask, what exactly is driving the need for modernization in the water and wastewater world? In the next slide, you can see this. Modernization drivers can be reactive or proactive, right? So to the left side here, the reactive driver is obsolescence. Utilities react to parts obsolescence and even skills obsolescence due to funding or lack thereof. The life of the existing assets may need to be extended. You know, can they squeeze every last year out of the service life of what they have? Can they find the parts? And like that cartoon, can they find the people that understand how to run it? Then on the right side here, there's the proactive approach, like, hey, there's new technology out there, there's new products with new features, we can get more data, you could run with less manpower, there's more alarms, it's safer, it's more secure, whatever. So in this next slide, I'll show you exactly what I'm talking about. I'm sure you recognize some of these, right? PLC 5s, slicks, old drives, FlexIO on the obsolete 1794 ASB adapter. To keep this stuff alive these days has gotten to the point where you have to rely on eBay for sourcing parts. You know, this is where phase migration can be considered as a possible alternative to rip and replace. So here in this next slide, you'll see phase migration broken down. So one potential avenue to modernizing all this old water automation equipment is phase migration. So unlike a rip and replace where you tear it all out and replace it with everything new, a phase migration allows you to modernize in stages. Look, the biggest risk factor in any migration is usually the PLC or troubleshooting the new code. Or when you have a bunch of end devices like this, you know, shown here on the right, you have panel view HMIs or IO or 1336 old drives on Bluehost. These all add to the challenge. In a perfect world, you would modernize the end devices first, but the new modules don't support Bluehost. So I'll show you on this next slide how you can mitigate the risks. First of all, you can leave the PLC alone, and you don't even have to touch the old code. You can take a modernization gateway configured as an adapter that takes Data Highway Plus or Remote I/O and brings you to Ethernet IP. On the top here, you'll see that the 1336 drive was replaced with an Ethernet-based PowerFlex drive. In the middle, the PanelView Classic was replaced with an Ethernet-based PanelView. And on the bottom, the obsolete 1794 ASD adapter on the Flex IO was replaced with a 1794 AENT adapter. That is phase migration. We changed out the peripherals, we left the PLC untouched. So you may say, well, that's great, but what if you want to do it the other way around? What if you want to change the PLC but leave everything else alone? On this next slide, you'll see that you could do that too. So what I'm about to show you here is textbook phase migration. Here you see a slick with a bunch of remote I/O drops. The important thing to note here is this. These I/O racks are on a remote I/O network, which means there's going to be a lot of engineering and a lot of labor involved if you want to do this all at once. Remember earlier we said, risk and funding, right? Both apply here. A phased approach here would allow you to begin by replacing only the PLC using that same gateway that was shown in the other example, but this time configured as a scanner. So as we move to this next slide, you can see that if the field I/O still works, then we didn't have to touch that. Now you have Ethernet IP in the system and a current platform that can be connected elsewhere. And when time and money and other resources permit, you can see the progression in this next slide. One by one, you can migrate the individual I/O racks until all the I/O platforms are on Ethernet IP. This is phased migration. So moving on to this next slide, in addition to phased migration and the examples I just ran through, you can also do bridging. So what is bridging and where would you use it? Well, when you're talking water and protocols, you're probably talking DNP3, and if there are slicks in the system, then you may have DH45 or DF1, who knows, ControlNet, DeviceNet, any of these protocols listed here on the left. So as we move to this next slide, you'll see what this looks like. So here you see two separate isolated systems. The older Data Highway Plus network on Bluehost, shown at the bottom, the newer Ethernet IP network shown at the top. Both of these systems are running, but the older one is isolated. You can extend the life of that older functioning asset by bridging. Watch as we transition here in this next slide. So in this case, you indirectly modernized that older network. You added connectivity to a network that wasn't connected in the first place. This is important to water because now you have access to that network and to its data. So now in this next slide, we'll touch a little bit on non-Rockwell. Right, everything I've shown you so far was basically migrating old Rockwell to new Rockwell. Well, you can do the same thing with legacy non-Rockwell systems. Looking at this list here, you can do a phase migration from any one of these legacy non-Rockwell platforms to current Rockwell. In this next slide, I'll show you one example with SCADAPAC. So if you're competing against SCADAPAC's RTU, or if you're upgrading from an older SCADAPAC RTU, odds are you're going to need DNP3 functionality in the new RTU. So here you see some options. The MicroLogix 1400 has native DNP3, but ProSoft's DNP3 router can be added to a Micro 800 or a Compact Logix platform to give them DNP3 capability. I'm going to take a closer look at DNP3 in a later slide, and I hope I'm not boring everyone with these examples. I promise I only have one more. So these next few slides are going to show you a DF1 migration. So you can't talk water without somebody bringing up DF1 and leased line modems, right? And of course, Rockwell discontinued their 1761 net ENI back in 2017. So what do? Well, again, you can do a phase migration here as well. And here's an example. This next slide shows a typical architecture. So the current architecture might look something like this. You have serial RTUs in the field connected to a central SCADA by way of leased line modems, right? So to initiate a phased migration, you might do the following. First, we'll get rid of the 3 serial RTUs shown on the bottom. So in this next slide shows step 1. You see here, we've eliminated the serial RTUs and replaced them all with compact logics. And we've added DF1 gateways between the new PLC and the old lease line modems, which are still in use. In step 2, on the next slide, we'll update the SCADA shown at the top of the image. So now in phase 2, we've upgraded the SCADA to Ethernet IP. We've added another DF1 gateway between the new SCADA and the existing leased line network infrastructure, which is still on DF1. Now in our last step, on this next slide, we'll replace the lease line modems one by one. So here, if you look at the site on the right, you see that the lease line modem to that site has been replaced with some form of wireless, either 802.11 radio or cellular with PDN. Brian's going to touch on this in a bit. So on this next slide, let's go back and look at the big picture. To summarize modernization with water assets, you can do a phased migration to extend the life of existing assets, which are scattered all over the utility, as shown here, and you can lower the risk. In the end, you're going to end up migrating and modernizing everything anyway, but doing it this way, you could do it at your pace, on your budget, with minimal risk. Now let's move on to this next slide to see what else we can do. So in many process systems, you'll have machines, instruments, controls, each with their own protocol. Water is no different. Scattered throughout a water utility, you may have level sensors or flow meters or pressure transmitters on HART. You may have valve controls on Modbus Serial or Modbus TCP, Profibus and Profinet devices, ControlNet, DeviceNet, or you may have clients like an HMI client or the plant business client or even a SCADA client on OPC UA. You need to reliably connect these disparate systems. This is ProSoft's specialty. This is our bread and butter. This is what ProSoft was founded on. And this next slide captures that pretty well. So here's a quick factoid. As Brian mentioned, ProSoft was founded in 1988 by Doug Sherritt. He was working for Chevron at the time, and he needed to get Modbus data into a PLC-2, and thus ProSoft was born. 30 some odd years later, we have over 40 protocols with 100+ gateway combinations. The image you see here shows a gateway with dual subnets connecting Ethernet IP networks to a Modbus TCP IP network, each on their own subnet. So if we look again at that slide showing the big picture, we've modernized legacy or obsolete assets scattered throughout the utility. We've connected disparate systems throughout the utility. What else can we do? Well, on this next slide, I'll show you how to improve data integrity. So as I showed on an earlier slide, we can help displace Schneider's SCADA pack and other RTUs with a combination of ProSoft's DNP3 gateways and select Rockwell PLCs. This next slide will explain more about what DNP3 is. So DNP3, Distributed Network Protocol. This particular unit you see here is a new product for ProSoft. The DNP-S router came out about a year ago. The DNP-M master module is scheduled to be available for release in September, so next month. They're primarily used in the water and power industries, but what are they? Well, these are secure, intelligent gateways that provide routing between DNP3 and either Ethernet IP or Modbus TCP IP. These units support both Ethernet and serial communications. The master module can communicate with Ethernet IP or Modbus TCP field buses and convert them to DNP3. It can be configured as a data concentrator where it'll act as a master to other remote units and also an outstation to a DNP3 SCADA master. They're both optimized for Rockwell customers with features like device level ring, DLR, or direct-to-tag technology. And for water utilities, they ensure data reliability and no loss of data for remote connections. They improve system efficiency and performance with unsolicited reporting, data classification, and the data is timestamped at the source. They're industrial hardened, ODVA certified, and they have SD cards for disaster recovery. So once again, if we go back and look at that big picture slide, We've modernized legacy equipment through phase migration. We've connected disparate systems across various protocols, and we've improved system efficiency and performance with DNP3 routers. And with that, I'll turn it back over to Brian.
That's perfect. Thanks, Vic. So we essentially just looked at each site to make sure everything's communicating at that particular site and to make sure we have a high level of data integrity. Now we can make sure all of the islands of automation are talking to each other. First, looking at a single location. So we can start by looking at this water treatment plant. So you've got your clarifiers with some automation, your filtration system with some automation, and of course your SCADA system. Here we can leverage wireless Ethernet radios to ensure that all of these sites can communicate to each other and to have that connected process that we need, all with the major benefit of not having to run cables through your water treatment plant. So we can look at our purpose-built wireless Ethernet radio solution here. So with wireless Ethernet from ProSoft, you can do a lot with these types of applications. With our ultra reliable radios, you can connect your access point or your master to your main control room or your main PLC. And then you install a radio at each location with automation to kind of act as that wireless bridge to connect all of your sites over wireless. So now that you have that connectivity, to really help you digitalize your plant, we can look at what else ProSoft can do that makes these radios a little special. So these radios can be configured as your master or as your access point, which is typically connected to that main control, but they can also be configured as a repeater, which means that they connect your automation, they act as that wireless bridge, and then they also extend or repeat the signal from that master. And that enables things like a mobile worker with a third-party client, like a laptop. So it's a really effective way to efficiently connect your in-plant automation without the need to run and trench cables. So if we look at this image on the right, where radios provide that wireless Ethernet link between the water clarifier and the plant network, this is exactly what we're talking about right now. We see a ton of applications like this. There we go. So here's some details of what that might look like. These clarifiers have remote cabinets. They have several electronics to control that clarifier. End users don't want to invest the time or the money to trench cables back to that main controller. So we come in, we can offer an IP67 radio in each clarifier, an IP67 radio as a master connected back to the main control. And then after ensuring we have line of sight between those radios, we can leverage MIMO omnidirectional antennas to ensure that there's a reliable connection throughout the entire plant. So beyond the ease of use during installation, which is important, these types of deployments enable that mobile worker to connect to the system without plugging into the main control. And we're actually increasingly seeing that as a use case, since wireless enables increased connectivity of your automation and also more efficient workflows for the end customer. So it's really becoming popular for in-plant connectivity. Also in applications like this, where wireless is outside, potentially in a public area, you want to really make sure that that link is secure. So on the security side, we leverage the industry standard WPA2 AES encryption. We have options where we can hide the SSID to prevent a malicious operator from seeing it. And we have the option to digitally attenuate the signal, meaning that we can reduce the amount of Wi-Fi that extends beyond the distance of this application. And we can even enable something called secure bridging mode, which means only ProSoft radios can connect to this network and all the automation that's connected to those radios. So we have several options here to ensure a secure implementation. All of that's really important. So now going back to this overview, now that we've modernized everything, we're ensuring everything's communicating, we just verified that everything in plants, all of those islands of automation are connected and communicating with wireless Ethernet. The last step in our smart water journey here is to really ensure that we have a secure and reliable data network for all of our remote sites. So this is where we can leverage our persistent data network powered by ProSoft Connect to connect your geographically dispersed assets. This really is the most secure, the most reliable, the most future-focused solution on the market for interconnecting multiple remote sites, no matter where they are. So previously, you may have considered an antiquated technology like a 900 megahertz frequency hopping radio for long-distance I/O communication. Well, that's proven slow, it's proven unreliable, really hurts the future flexibility the end users have with this application. So to better enable these types of applications, to make them more reliable, we can now leverage ProSoft Connect to connect their sites over cellular or to connect those sites over a local internet connection to really enable the connectivity and digitalization required for a smart water application. So with PDN, we focused on ease of use and enhanced security to develop an always-on VPN connection between remote sites. This solution does not require external software. It doesn't require an expensive VPN server to be purchased and maintained at the customer site. It doesn't even require networking expertise to deploy or maintain the system. Our platform, ProSoft Connect, takes care of all that in these types of applications. You can think of ProSoft Connect as ProSoft leveraging computing power in the cloud to offer an easy to use and understand user interface for configuration, for diagnostics, and to offer industry-leading tunnel encryption that adds an extra layer of security, and to offer several other unique features that enable things like securely remoting into a remote site to service equipment without the need to send a tech out. All while ensuring that the end user has complete control over who remotes into each site, when they remote in, how long they remote in, and even what devices they have access to while they are remoting in. All you need for a persistent data network like this is a cellular modem or a network bridge from ProSoft and a ProSoft Connect account. So with this technology, we see a lot of projects in this space, in this water wastewater market, where customers are updating their remote sites. They need faster update times for their SCADA system. This technology has a lot of value we're seeing for integrators in these markets who are able to easily specify and deploy this network and then remote in at the customer's request to provide support for those remote sites in this application. So beyond the ease of use and security benefits that we just talked about, ease of deployment in this market is also important. So with PDN, you don't need to erect tall and unattractive towers with large and expensive antennas. In many applications in the water wastewater space, the locality actually won't allow new towers or large antennas to be installed due to the aesthetics of the environment. So PDN is secure, it's reliable, it's easy to deploy, it's easy to maintain. We do it for you and we guarantee 99% uptime. And you don't need to be a networking expert to deploy it. It's the perfect way to connect all of your sites through your water wastewater application. So it's also worth mentioning that these types of applications with PDN, with these remote sites, also benefit from data monitoring at those sites. So I want to highlight here that we also have a really nice data logging solution. Our solution offers a huge max record count with 50 millisecond intervals for up to 200 tags. And this data logging solution the data can be exported as a CSV file. You can interface to other software with REST API. And we even support the Excel reporter system from SciTech. So if you use their forms or their dashboards, this data easily integrates into that. So through all that, we talked about how easy PDN is to deploy, but I want to show you through a few screenshots to really illustrate how easy it is to deploy a highly secure future-focused network in these types of applications. So it's as easy as installing a ProSoft gateway at each site. Then you create your account with ProSoft.io to connect your gateway to your PDN application. Then you create a project specific to that network, and you give the end customer, the end user, administrative rights for those special features like virtual lockout tagout, vLotto, or IP whitelisting, which ensures that they have complete control over their application that controls who remotes in, what they remote into, how long they remote in. And in the event that they want a partner or a service provider to remote into that remote site, it's important that we do that here. Then, if this is a PDN system, everything's now connected. And if you wanted to remote into that site to service your equipment, it's as easy as hitting this connect button and entering the one-time unique passcode for that gateway after the administrator, the end customer, accepts your request. Then all key metrics of the persistent data network solution are available on this webpage for future use. Everything from activity logs to cell signal strength to VPN data usage. It's all available on that page. It really is this easy to deploy a long distance, highly secure network like this. So that's it. We made it through your smart water journey. And I hope in the past few minutes, we efficiently answered this question for you on why ProSoft. You know where to help you. We're here to help you connect all of the different parts of your application. We help you through your phase modernization with our portfolio of modernization gateways. We help you through connecting your dissimilar systems with our industry-leading portfolio of protocol converters. And we help you simplify your network, both in plants and across the entire application, with our wireless Ethernet portfolio and our persistent data network solution. And the end result of all of this is that we help you minimize your downtime and we help you digitalize your system. So that being said, you have a partner in McNaughton-McKay, you have a partner in ProSoft. Keep us in mind as you start or as you continue your smart water journey.
Thank you so much. That was a wonderful presentation, and we do have a question here in the comment section I'd like to read out now. The question comes from Steve. He asks, is data logging tied to ProSoft Connect OR radios? And Kaz did answer this question. He said, I believe the data logging is tied to the gateway physical device, but I wanted to give you the opportunity to answer this question as well.
You want to take that, Vic, or do you want me to?
Sure. So the data logging is local in the device. And then the question is to how you access it. We have the standard data logger, you manually retrieve it. And then the data logger plus, you can access it remotely, as Brian alluded to in his presentation.
Great. And if you have any other questions, feel free to drop those in the comments now. Vic and Brian can answer those here. We do have some frequently asked questions we might want to cover as well. One of those would be, what happens if I have a device with a protocol that you didn't mention here today?
Brian, I'll take that one. So on the ProSoft website, we have a product selector. Basically, if you go to the ProSoft website, www.psft.com, you can hover over products, and then you could pick either an in-chassis module or a gateway. And then it gives you two selections, right? Protocol 1 to Protocol 2. If you can't find it there, which I think you will find it there, but if you can't find it there, give us a call, talk to a regional sales manager or a ProSoft tech support, and we'll see what we can do to help you out.
Awesome. And do you have frequency hopping radios? That's another question people might have.
I could take that one. We do not have frequency hopping radios. We actually used to. We replaced that portfolio with PDN after seeing that frequency hoppers typically don't meet the refresh, the data rate requirements, the security requirements, and the scalability requirements. So we built all that into PDN, which is a really great solution for all those applications that frequency hoppers historically may have been used for.
Great. And how large can a PDN system be?
That's a good question. We see all different sizes. We see systems as small as 2 points and as large as 200. It's a really scalable system. So we've got a great tech support team that can work with any size in these types of applications and try to figure out the best way to deploy the system for you.
That's great. Lots of versatility. Well, wonderful. Thank you again so much for this presentation. We have a few folks out in the comments thanking you for this presentation as well. So this was really needed. If anyone watching here today has any follow-up questions or thinks of some questions after this presentation, or if you're watching this as a recording, you can always reach out to us at that email address there on the screen, macandmaclive@mc-nc.com. Just be sure to let us know the title of this session so we can get your questions to the right person. And thank you to Brian and Vic for this amazing presentation for ProSoft Technology. Thank you to Kaz for being our resource out in the comments section today. And thank you to all of our live viewers who joined us here today. We hope this session was informative and engaging for you. Remember to subscribe to the McNaughton-McKay YouTube channel for more industry content like this, and we look forward to seeing you live again soon. Thank you, everyone. Have a wonderful day.